Hi, everyone. Welcome to the Urban Climate Adaptation and Mitigation Program. Today's session 1, Climate Science and Impacts. So on today's agenda, we'll be covering a program overview, climate impacts in the Northeast and New York agriculture, an introduction to climate science, as well as questions and next steps as part of the Urban Camp program. So our team consists of a few collaborators, including Climate Smart Farming, Cornell Cooperative Extension, Harvest New York, Sea Grant, and the Northeast Climate Hub. Now I'll let Allison introduce herself.
Okay, hi everybody. I'm Allison Chatharjan, and I'm a research associate at Cornell University in the Soil and Crop Sciences Department. And I am from the team from Cornell University. And the first partner that I want to talk about is a program I've been running since 2015. It's called the Cornell Climate Smart Farming Program. And you can Google it at climatesmartfarming.org. The nice thing about it is that anyone in the Northeast, any farm, any gardener from Maine to West Virginia can log on and enter their zip code in any of the tools that are on the site, including a growing degree day calculator and a water deficit calculator, and also this really cool tool that shows you how climate has been changing in your county. And also link to educators like Yolanda and Savannah from Cornell Cooperative Extension, Harvest, New York. Okay, great. Next.
Great. So a bit of background on Harvest New York. The Urban Ag team is located in New York City as well as Buffalo and covering Rochester as well. The goal of the Harvest New York regional team is to advance agricultural industry in New York State. So we have presence in there's a Cornell Cooperative Extension in every county of New York, and the Urban Ag team is present here, and we have offices both in Midtown Manhattan and in Brooklyn. Next.
Hi, everyone. My name is Kayla Walsh. I'm the Coastal Climate Specialist at New York Sea Grant. I sit in Stony Brook, Long Island. Sea Grant is a collaboration between NOAA and state universities. 32 states have a Sea Grant program. We collaborate with Cornell universities, among other universities in New York. We take care of extension and research needs on coastal communities, Great Lakes regional communities, and are composed of a research and extension department.
Hi, my name's Kristen. I have a fellowship with the USDA's Northeast Climate Hub. The Climate Hubs were established in 2014 to serve people who work in natural resources with climate science, to take climate science and make it usable for people who work in natural resources. So the Northeast Hub serves everyone from Maine to West Virginia, foresters and farmers, by building tools with the science that's available, building trainings and providing them to people who work on the land and the people who support people who work on the land. And there are 10 hubs located throughout the states and one that does, it's like a foreign office. That's the hubs.
And so some background on the Urban Camp program. It started out through a NIFA planning grant back in 2017. There have been various collaborators, University of Vermont, University of Maine, that helped develop the curriculum. The first cohort was a dairy camp program, and that's Climate Adaptation Mitigation Fellowship. And now it's called CAMP, which is Climate Adaptation Mitigation Program. And over the years, there have been other sectors of agriculture that have participated, including row crop farmers, diversified ag and agroforestry, women and non-binary vegetable and small fruit growers. And so finally, we've been able to adapt the curriculum to include an urban audience. So that's what this program is all about. Next slide. A bit about the Urban Camp program. So we'll talk a bit about the program goals, the activities of the program, as well as a timeline, workshop session dates, and additional information. So program goals. The goal of the program, of the Urban Camp program, is to provide relevant, regionally specific climate change information to urban growers, essentially taking all the information that's out there for rural farmers and adapting that for urban growers. The second goal is to empower farmers and advisors who are already thinking about climate change to become climate leaders in their communities. And we do this through peer-to-peer learning, networking, and information sharing. And third is to provide an opportunity for farmers to generate farm-specific climate adaptation or mitigation plans, and we'll talk more about that at the end. And that is done through peer and project support, both from Extension and from other ag advisors. And finally, enable agricultural advisors to strengthen their climate adaptation mitigation planning, their knowledge and abilities through hands-on work and with urban farmers. Next. So the Urban Camp activities will have a series of in-person workshops as well as additional online expert speakers based on participant interest. So if there's a topic that you would like covered, we'll definitely make sure to have an online webinar about that. In terms of farm resiliency planning, we're also looking to do an on-farm climate risk assessment and identification of adaptation and mitigation practices, and then ultimately have a climate resilience plan or an adaptation mitigation plan. The timeline, so we're looking to start in February, March with in-person workshops. And then in April, May, have optional webinars. In July, that's when we would start the optional farm tours, including an agroforestry field tour series, and then additional field days organized by the Harvest New York Urban Ag team in the fall. And then lastly, in the winter, have a farm adaptation and mitigation plan. These are the dates for the upcoming workshops. The time commitment, we're looking for attendance of all 5 in-person sessions, a willingness to work to develop your farm resiliency plan. We estimate around 10 to 20 hours of work, but you can take as much time as you need, as well as farmer-to-farmer program sharing and end-of-program recognition, along with a stipend to help cover any costs associated with attending any of these events. Following the workshops, we'll be focusing on farm planning, so participating both online and in-person trainings, gaining access to resources from subject matter experts, developing a farm-specific climate adaptation or mitigation plan, sharing your climate change farm plan or experiences with other farmers, and finally engaging with other producers and ag advisors at farmer field days or farm tours, networking meetings, and other relevant events. The photo here on the right is actually our Urban Ag Climate Field Day at Brooklyn Grange. And that's an example of a type of program that we would have in the city as part of this program. Next. And Allison, I'll let you explain a bit about Canva.
Okay, so this is a cohort of trainees that we are working with through Urban Camp. And so everyone that is taking the course will be added to our Canvas drive along with a Google Drive, where we will place the PDF of these slides so that you want to go back and watch them. We have set it up. You can see the Canvas here. It's a learning management system that we use with students at Cornell. It's a great, easy to use system. So if you want to get access, if you haven't figured out how to use it yet, let us know. Next. And so how to access Canvas. If you've joined the program, we will add you to the Canvas. You'll get an email invitation, and you do need to accept the course. So it can be a little tricky, so don't feel free to reach out if you can't figure it out. But all the resources from the course will be there so that you can go back and watch them again. All right, Savannah.
All right, I'm gonna take it over. My name's Savannah Shelnut. I'm the Ag Climate Resiliency Specialist with Cornell Cooperative Extension's Harvest New York team. I'm based in the Hudson Valley and I help farmers adapt to mitigate climate change. So just really quickly, I'm gonna give a brief overview of climate science to give us a little context for why we're here participating in this program. And then Allison will hit it in a little bit more detail later on. So really quickly, I just want to show this animation from NASA. It's looking at the average the mean temperature change over time, beginning in the early 1900s all the way up to present day. And you can see that the mean temperature is gradually increasing as we move along in time. So here we are, 2023 was, I think it was the hottest summer on record at the time. And you can really see that peak forming right there. So, why is this happening? So this is another great visualization provided by NASA. It's looking at CO2 concentration in the atmosphere, and it's a combination of, in yellow here, we have ice core data, and over here we have data collected from modern instrumentation, and that begins around 1958. So you can see that for thousands and thousands of years, we kind of stayed below this 300 ppm threshold. And right around the age of industrialization over here, you can see that suddenly the atmospheric CO2 concentration begins to spike. And with that, as we've seen in the previous slide, we're seeing increasing heat. Another way that we can visualize this is through this interactive map that's also provided by NASA. So as we move along from the late 1800s to present day, you can see the areas that are more blue are cooler than the average, and then the areas that are more red or orange are much warmer than the average. So as we creep up to present day, you see that we have more and more of these areas popping up in red or orange. We're getting hotter, less areas in blue or white. So moving on. So throughout this program, we're going to talk a little bit about how this change in our atmosphere, how this increase in temperature is shaking out and impacting urban farms. So we're going to discuss a little bit about how increasing temperatures, precipitation, and frequency of extreme events might impact urban ag and what we can do to help mitigate or adapt to some of those issues. And then we'll also get into a little bit more detail on how these changes will impact plant animal behavior and weed, insect, and disease pressure. And throughout the program, just kind of keep in mind when we're talking about adaptation or mitigation, these are some examples of what those practices might look like. So for adaptation, you might think about improving your water management system so that you're better able to provide water to your plants or livestock during times of extreme heat or drought. You might think about diversifying what types of crops you're growing. So you're growing something that's better adapted to our new environment. And you might think about having an extreme weather preparedness program plan in place, or doing some infrastructure improvements to help protect farm equipment. And then when we're talking about mitigation, we're talking about things like electrification, installing solar panels, applying biochar or rock dust to help sequester carbon in the soil, and improving our nitrogen use efficiency to reduce emissions into the atmosphere. And then some of these practices are both adaptation and mitigation measures. So something like agroforestry allows you to keep your crops and your animals nice and cool under the canopy of the trees, but it's also sequestering carbon in the trunks of the trees. And something like conservation tillage might allow you to see some benefits in terms of soil moisture retention, but it also increases soil carbon. So that's where we're mitigating the carbon going into the air. And then cover cropping, similar to conservation tillage, you're increasing soil organic matter, therefore increasing carbon in your soil, reducing carbon in the atmosphere, but you're also improving a lot of soil health properties. Maybe you're providing more food for microbes in the soil that are then converting that over to usable material for the plant, etc.
Yolanda, do you want to take it over?
Okay, great. So The regional effects are multifaceted. So earlier we saw how the climate is warming globally from 1880 to 2022. And what we want to cover today are the changes that we are seeing where you are farming in the Northeast. Temperatures have risen across the Northeast. Average annual temperatures have increased by 3 degrees Fahrenheit since the 1970s. And this trend will likely continue for decades. Warming trends in the Northeast have mostly been in the winter months, and daily minimum temperatures are increasing faster than daily maximum temperatures. And this is just along with all these other regional effects, like we're seeing extended mud season, heavy snowfalls, more frequent weather events like big rains, more rain during all seasons, drought intensity, and sea level rise. Next. And so we're pulling data from the latest National Climate Assessment. So this is an assessment that has been worked on by 750 scientists. It includes 32 chapters and an interactive atlas. All the data that we're going to be showing you now is observed data that has been reported in the latest National Climate Assessment, which has been published in November of 2023. And here's the latest one for New York State. This is the agriculture chapter. And so this QR code takes you directly to this chapter, which includes case studies. It includes more information specific to New York State. And we'll be talking about that in the upcoming slides.
All right, I'm going to take it over. Thank you, Yolanda and Savannah, for that great introduction. So we want to spend a couple of minutes really showing you how the climate has already been changing in the Northeast, and that includes urban areas like New York City, where farming is increasingly happening. So what you see here is that since 1900, again, Savannah mentioned the Industrial Revolution, we have data that shows that temperatures in New York State have risen by almost 2.5 degrees Fahrenheit, and temperatures are warming faster along the Northeast coast. So you can see the red line on this graphic. It shows that this is a significant change. It's not just a random change. It is statistically significant. And it's happening much more in urban areas as well. This relates to the urban heat island effect. Next slide. So we also know that in general, temperature is increasing at a really fast rate, but also that winters are warming faster than other seasons. And so you can think about that. That means that there might be less snowfall that stays on the ground or on the mountain, in the mountain areas, leading to less water that's available for runoff. So in the north and eastern parts of the United States, the average temperature in the winter has risen 3 to 6 degrees since 1970 alone. Next slide. So often you may hear people say, well, it's really cold out there, so we can't have climate change happening, or there's no such thing as global warming. We often refer to global warming or climate change. They say it's so cold out there. How can it be? How can the climate be changing when it's so cold out? Well, one thing that we have seen recently in the last couple of winters in the Northeast is called a polar vortex. And this is actually, scientists are starting to study this more and more. They think that this is because climate change is not only changing temperatures, but it's changing wind streams, changing patterns in the jet stream. So it's actually causing a lot of things. The world maybe seem to be turning upside down, topsy-turvy in a way it kind of has. This is because what's happening in the Arctic, where it used to be warming, where it used to be so cold, it's warming twice as fast than the rest of the planet. So when the Arctic is off the charts warm, we're more likely to see frigid cold air get trapped in a jet stream that gets stalled in places like Texas or even in New York State. We get these Arctic cold air that gets trapped. Next slide. One really important change that affects places like New York City or Boston or Providence are urban areas where we see a lot of agriculture happening, is that we have an urban heat island effect. And with climate change, and these rising temperatures, the places that are going to warm the most are actually these cities, because they have a lot of infrastructure, a lot of pavement, a lot of impervious surfaces, less trees to cool areas. And so these inner cities can actually be the warmest of all, can be between 1 degree Fahrenheit to 7 degrees Fahrenheit warmer than rural areas. Next slide. So you can see this with this data of showing the summer temperature differences by neighborhood in the Bronx in New York City, where average summer temperatures are generally higher in historically redlined areas in the Bronx. Unfortunately, these are areas that were historically impoverished areas in inner cities. There's less tree cover, there's more impervious surfaces, and these areas are where we see the impacts of climate change are affecting areas, inner city areas, much more drastically. So, for example, this graph shows that areas with lower socioeconomic status and higher percentages of racial and ethnic minorities, for example, in the Bronx, from the period of 1981 to 2010, you see much higher temperatures in the most redlined areas, unfortunately. So this is just an example that the climate impacts in the United States and around the world often affect more impoverished areas or racially diverse areas more strongly. Next slide. And so what you see here, let's look at some data that talks about growing degree day seasons or pest, things that affect agriculture. So what you see here is that growing seasons in the Northeast have increased by 14 days since 1895. And what does that mean? The growing season is defined by the EPA as the average length of the growing season in the contiguous 48 states. And it's increased by more than 2 weeks since the beginning of the 20th century. And you can see here where we are working in the Northeast, in New York, on up to Maine. We see changes in length of growing season days. We are sort of in the light green area, the more where you can see California. The growing season has increased even more dramatically by several days. Okay. In addition, next slide. What we've seen is, if any of you are gardeners or you're definitely growing crops, you are aware that we have something called plant hardiness zones. And another way that we are experiencing shifting temperature dynamics is in the warming of the annual minimum temperatures. These minimum temperatures are critically important for determining what plants will survive the coldest winter conditions in any given area of the United States. So we use these temperature trends in a way to create what's called plant hardiness zones. If you're choosing a plant for your garden, or an urban farmer is choosing a particular species of crop to grow, then they want to choose one that is going to survive in the coldest temperature. And what you may not know is that these zones are based on 30-year average temperatures. And what we've seen is that basically there's been a shift in these plant hardiness zones upwards. And if you're interested in this, you can actually go to this link at the bottom of the slide here and zoom into your particular area and see what zone you're in. And this would be very different from what it would have been 30 years ago. It's just another example of climate changing. So if before you could plant crops rated for a 8A zone, plant hardiness zone, for example, you can now likely plant species that could survive an 8B zone. Next slide. And this is just another way of showing this. In 2012, you can see these were the plant hardiness zones. And by 2023, the picture looks very different for much of the Northeast. Next slide. Okay, so another thing that we're really interested in as farmers is what is called a growing degree day. And many of you may know what that is, but if not, I'm gonna give you a very overview of a definition here. In a nutshell, a growing degree day is also known as heat units, and we use them to estimate when in any given growing season, the crops will develop to a point where they can be harvested, they're ready to be harvested. Or we can also use those heat units to understand when pests or beneficial insects may go through different life stages. We can use a simple formula for keeping track of GDDs, or growing degree day units, which you can see up on the slide. Basically, when you take the maximum temperature for any given day, add it to the minimum temperature for that day, and divide it by 2. That gives you the average temperature for a 24-hour period. Then you can subtract what we call the base temperature. Most of the time we use a base temperature of 40 or 50 degrees, and that's what maybe some of you may grow corn. Use that base temperature for corn, but different species have different base temperatures associated with them. And how you would use this information, you could use it to very accurately determine when your corn would be ready to harvest. Or there is examples of insects like spotted wing Drosophila. And we know from past research and studies that the adults are likely to emerge at about a 510 growing degree day, and peak at about a 755. So if you know that and you can calculate that accurately, you would know when that's going to emerge. And the thing that relates to climate change is that actually in the past, farmers may have used a static growing degree day calculator that was just in a book, and it might have been updated every 10 years. What we know now is that we can very accurately use a growing degree day calculator online that is updating on a daily basis. And we can actually look at past seasons or even project the forecast for the future. And what we see is that you can look at your particular farm and see how it has changed over the 30-year period. And you can see that one growing season, like last year, might have been very much warmer than it would have been 30 years ago. So another way of seeing how the climate is changing. Next slide. So we want to start looking at observed and projected temperature changes. We've been talking about different ways to see temperature change, and also think about projected future changes. So this data here, don't get overwhelmed by it. You can see that on the left axis, we're showing temperature change in Fahrenheit, from negative 2.5 up to 15 for New York State. And we're showing the period on the bottom. from 1900 to 2100. And all of the data that's squiggling up and down over the years is because there's always a difference between winter and summer. But we see this general trend of temperature increases. And then what we see here is that we know with climate change, we have very accurate climate models that scientists at Cornell and other universities and agencies work on. And we don't really know where the temperature could end up. It really depends on how many emissions we have globally that affect New York State. If we all reduce our emissions, we would see a lower emission scenario. And if we keep emitting tremendous amounts of carbon dioxide and other greenhouse gases, the emissions are going to be higher. So what we do know is that there's a range here, and we should expect that temperatures will rise between anywhere from an additional 5 to 11 degrees Fahrenheit by the 2080s. We can project that temperatures will be warming more along the Northeast coast. And the dark red is showing 2.5 degrees Celsius, which converted to Fahrenheit would be the higher end of the range. All right, that's what we can expect in the future with climate, with temperature changes in the Northeast and New York State. So next slide. Okay, another way of looking at projected change is to look at all of the states in a map of the United States and look at this change going forward. So the United States is projected to warm faster than the global average. That's really a little bit scary to think about. As the world warms, the United States is going to warm as well. Projected temperature rises are larger in the northern and western portions of our country and are most severe in the Arctic, actually. This map shows projected changes in annual average temperature for various global warming levels. So you can see here on the upper left-hand corner is the lowest amount of change. Actually, again, if we emit much lower greenhouse gases, then we're expected to have a warming across the United States of about additional 1 degrees Fahrenheit. I can't really see that, Savannah. Is it 1.5? 1.5. And then if we, you can see on the bottom left-hand side, the greatest amount of warming is up to 4 degrees Celsius. So that would be an incredible change in temperature. Think about how that would affect urban farms and farming in the Northeast. It would be really, really hot. Okay, next slide. So let's talk about precipitation. We've been talking about temperature. So let's start by looking at some historical data. And again, this is all observed data that we track through our weather stations that actually catch the precipitation and measure it. So since 1960, precipitation in New York City has been increasing by 0.92 inches per decade. That's quite a lot of increased precipitation. That's almost an inch per decade increase. You can see the change here on the graph over time. And what you see is 2 lines there. They mean that it's a statistically significant increase in precipitation. So yay, we are very lucky in the Northeast and in New York State and New York City. We have water. Many other parts of the world don't have water, or with climate change are experiencing more overall dryness and drought. We actually have an increase in precipitation, which is great, but it makes it challenging. There's a lot of challenges with excess precipitation. And as we go throughout this entire workshop, Savannah and Yolanda are going to talk more about the challenges of excess water for growing crops. Next slide. So that data was New York City. This data is showing that the Northeast has experienced a 60% increase in extreme precipitation since 1958. So what's the difference between those two data points? The first on the last slide was talking about the general trend of precipitation. This slide is talking about extreme precipitation. So we know, and you probably know this as a farmer, the way we get our water is very different than we used to get it. And we used to get steady rainfall events. We'd get a little bit of rain or a rainy week, but it wouldn't rain very much at a time. Now we know that on average, we're seeing this increase in precipitation, but we're seeing these very, very heavy rainfall events. So a positive value on this graph indicates that more of the precipitation is falling each year as part of heavy precipitation event. The threshold used to define a heavy precipitation event is the top 1% of all days with precipitation. So think about it as if you were looking at the entire growing season, the heavy precipitation events would be when you get the top % of those precipitation events. And we know that rain is falling more in those events. And between those events, we're actually experiencing more drought. So in 2016, 38% more precipitation was falling in those heaviest 1% of rain events. You get a deluge of water than happened in 1901. Okay, next slide. Another way of seeing that data, I kind of love this graphic. We show it a lot because this shows that across the United States, we are seeing an increase, you can see along the bottom, from 0 up to 40% plus, an increase almost everywhere in the United States, except Hawaii, I believe, which has a negative 11%. They're getting drier. Everywhere else in the United States is seeing this increase in heavy extreme precipitation. But look at the Northeast where we are, and we've seen a 55% increase in these heavy rainfall events. So you know this, if you think back to how did it rain last year during the growing season, it came down in these very heavy rainfall events. And that's hard for farmers to deal with. Okay, next slide. The Northeast, so a summary, the Northeast is experiencing more extreme precipitation events and a higher proportion of overall precipitation that's falling during these events. So it's not only that there's more of these events, but overall the amount of rain that you would see in the season, it's happening in those extreme rainfall events. Next slide. Another way of looking at this data, the 4 charts here show the number of daily events per year with precipitation totals equal or exceeding 2, 3, 4, and 5 inches. And they've all increased. More rain is happening in these heavy rainfall events. This is just showing you a farm in New York State that was inundated with rainfall that caused a lot of flooding. Next slide. Why is this happening? Well, warmer temperatures means that more precipitation is staying in the atmosphere. We see slower storms and then heavier rainfall and more frequent storms because the atmosphere holds more water vapor. So it holds onto it longer, and then when it does finally rain, it's letting more of that precipitation happen. Next slide. So along with all these changes, we actually refer to climate impacts as climate change and not just global warming. We're not just talking about temperature rise, because globally the rise in greenhouse gases is causing temperatures to increase, which then causes a whole host of other things like the atmosphere holding more water. It's also causing our polar regions to lose ice, and that has caused the sea level to rise. Changing sea levels can affect human activities really greatly in coastal areas. You may not think about this, but this image is a street in New York City, and anywhere that's a coastal area, a lot of our coastal lowland areas in the city, we see rising sea levels, and we see flooding happening even on days with high tide. So it's not just happening during these extreme storms, it's happening often on a regular basis. Rising sea level inundates low-lying wetlands and dry land and urban areas. It erodes shorelines, contributes to coastal flooding, and increases the flow of salt water into estuaries and nearby groundwater aquifers. And so after a period of approximately 2,000 years of little change that's shown here, global average sea level rose throughout the 20th century, and the rate of change has accelerated in the most recent years. So this is something that Kayla and New York Sea Grant are really focusing on. And if you are really interested in coastal areas where you might be farming, we definitely want you to reach out to New York Sea Grant. Next slide. So on the opposite of extreme of increasing precipitation is the issue of drought. And defining drought can be quite difficult actually, because it's somewhat subjective. So what is a good definition of drought? One common definition is put forward by the National Integrated Drought Information Center, and they define it as drought is a deficiency of precipitation over an extended period of time, usually a season or more, resulting in a water shortage. However, we should pause and recognize that deficiency is a difficult term to pin down. What one user may consider to be sufficient, another user may consider to be insufficient. So for example, a farmer that's really relying on groundwater and precipitation to recharge their groundwater may rely really heavily on groundwater, and they may experience a short-term drought, whereas others may not experience it. So what we see here is that there's been a change in drought conditions over the period of 1900 to 2022. And this is varied in most parts of the country, but you see here that the change in yearly observed precipitation, evapotranspiration, is quite high in the Northeast. Parts of Maine, parts of northern and Western New York are among the highest increases in evapotranspiration that leads to short-term drought. So next slide. So there is an amazing organization funded by the US government called the US Drought Monitor. It's actually at the University of Nevada, I believe, and you can access their data at droughtmonitor.unl.edu. We use it all the time when we talk to farmers, and you may want to use it if you're farming to get a sense where you are in your county or in your state, or you can see here the image of the Northeast on a daily basis or over the past season. There's actually forecast data there. So this data shows that in August 2016, that much of New York State and really focused on parts of the Northeast were experiencing abnormally dry conditions. And if you were farming in that time, that summer time in 2016, you might remember this as a particularly dry summer And why is this happening? Because perhaps the season before there wasn't as much snowfall. It was a warmer winter. We didn't see snow staying on the ground that could then be retained to refill aquifers. And we might see warmer, really, really warm summer temperatures in that August time period where we see more evapotranspiration happening that's leading to this short-term drought or lack of adequate water. So another way of looking at, next slide, another way of looking at changes in climate that are really important to farmers is looking at this observed increase in frost-free season length. Farmers really care about this because this frost-free season length is defined as the period between the last occurrence at 32 degrees Fahrenheit in the spring and the first occurrence of 32 degrees Fahrenheit in the fall. This has increased in each U.S. region during the period from 1991 to 2012, relative to a period of 1901 to 1960. So the more recent period versus the historical period, we've seen an increase in this frost-free season length. And in the Northeast, it's increased by 10 days. It's our frost-free season length is 10 degrees longer than it was in the past. Well, that's really important. Maybe that's actually quite a benefit or an opportunity for farmers. They might have a little bit more time to get in a crop or a double crop. But it's also challenging if one season is not quite the same as another and you might get hit with a frost. Next slide. So this, now we're going to turn to look at projections of precipitation. So what are we going to see in the future? So precipitation changes are projected to be larger with warming climate over time. And this map shows the projected changes in average annual precipitation for various global warming levels. So again, just like temperature, it really depends. We don't exactly know how much precipitation is going to change. It really depends on how much greenhouse gases we emit into the atmosphere. But at different levels, at 1.5 degrees more warming, or 2 degrees Celsius more warming, or 4 degrees, you can see there's quite different changes we expect with precipitation. And we know that here in the Northeast, we are going to see an increase in precipitation, which is quite important to know for us in the Northeast. We are going to have water. That's a good thing. Next slide. So increases, we're also going to have increases in the frequency and severity of heavy precipitation. This is showing you data. If we just say that we're going to see a global warming level of an increase of 2 degrees Celsius, we are going to see an increase in those events. On the left-hand side is showing you the heaviest 1% of days, the 5-year maximum daily precipitation, and then on the right, the annual maximum daily precipitation are all going to change. We're going to see an increase in the future of these heavy rainfall events. We're already seeing them, but they're going to get worse. Next slide. So I want to summarize this, and then I'll turn it over to Savannah. All of this data you can find in 2 places. One is the resource that Yolanda introduced. You can search it. It's called the U.S. Climate Impacts Assessment. And that has an entire section on agriculture and an entire section on the Northeast region. So you can really see how the climate has changed and what are the projections for the future. The other place, 2 other places. One is this NOAA State Climate Summaries. These are really great. They're just a 4-page, excellent fact sheet that describes how we're going to see climate impacts for each state in the Northeast, and you can kind of see this one is showing New York, and you get a really nice summary of what we just presented. The other one I want to highlight is the New York Climate Impacts Assessment, and there's an entire chapter there on how agriculture is going to be impacted by climate change. Great, next slide, I'll turn it over to Savannah.
All right, thanks, Allison. That was great. So now we're gonna speak a little bit more specifically about climate impacts on urban agriculture. And keep in mind, we're gonna go more in depth at a later date, but we just kind of want to top line this, get it on your mind so that you continue to think about it as we prepare and go through the rest of the sessions. So, briefly, Allison did a great job mentioning some of the impacts we've already observed or expect to see related to heat, but more specifically, I want to talk about how that's going to affect our urban farmers. So, with regard to plants, we expect to see an increase in evapotranspiration, which is when the plant is pulling water from the ground and giving it off into the air to help it do its photosynthesis, to help it remain water rich while it's just trying to go about and be a plant and grow. In addition to that, heat can cause elevated incidence of physiological diseases. For example, sun scald in apples. When the skin of an apple gets too hot, it causes it to become sunburned, and that can be a visible defect for some consumers, and it can cause some issues with texture sometimes. And then in addition to our impacts of evapotranspiration, when plants are too hot, photosynthesis is generally inhibited, and that can lead to yield reductions. And heat reduces pollination efficiency. It reduces the ability of pollen to be entirely fertile, and it can reduce its ability to dehisce or move off of the stamen and into the air so that it can hit the pistil and do the job of creating new fruits for us. With regard to livestock, heat can lead to decreased animal comfort, reduction in feed intake, which reduces our yield, whether that's meat, eggs, milk, and importantly, heat stress reduces egg quality as hens struggle to regulate body temperature. It can impact the thickness of the shell and therefore make them more brittle or easy to break, which is not something that we want to be seeing. Very importantly, heat also has a huge impact on people, and employee well-being is really key here. So you have to have a plan in place to figure out how you're going to help folks through heat waves or very hot times of the year. This can look like modifying work schedules to start earlier in the day or later in the day, avoiding those really hot periods in the middle of the day. Excessive heat can impact employee productivity, and heat exhaustion can lead to an increase in injuries when you're hot, right? You might not be paying the most attention. You could be more prone to tripping or dropping something. So just keeping an eye on the folks around you and making sure that they're taking plenty of water breaks and getting in the shade when they need to is going to be very key, and already is very key. So I mentioned that excessive heat can impact photosynthesis. We'll go more into this at a later date, but I just want to get this on your mind about why this is such an issue. So when when a plant is overheated, it inactivates one of the photosystems within the plant, and that can lead to a breakdown in the chlorophyll, and it can inactivate an enzyme that helps facilitate the production of sugars in the plants, which downstream can lead to a reduction in your yields. So we'll go a bit more into that, but just want to get that on your mind really quickly. And then switch over to talking a little bit about precipitation. So as Allison mentioned, we're going to continue to be a water-rich state, but we might see some of our rainfall come in more abrupt downfalls or be a bit more spaced out, and that can lead to some acute flooding or excessive wet conditions, which mostly impact plants when we're talking about farms. So acute flooding can cause damage to plants if they're sitting and standing or moving water for too long. Increased leaf wetness creates a perfect environment for pests like powdery mildew, downy mildew, all those fun guys. So keeping an eye out, making sure you're scouting for disease is going to be more important than ever. Using your IPM strategies to reduce the incidence of disease, very important. And then as far as livestock goes, the key thing to keep in mind here is that with all this increase in moisture, we'll be seeing an increase in mud and moist conditions, and that can lead to disease of for example, hooved animals' feet, an increase in abscesses, or if you're talking about chickens, it can lead to an increase of bumblefoot or other diseases that make it more difficult for them to walk. And making sure you know which areas on your farm are in a floodplain or more prone to flooding is very important when it comes to livestock. You want to make sure that they have the ability to get to high ground or a refuge whenever you have flooding occurring. And you want to make sure that they have access to clean water that's not going to be impacted by disease or bacteria that might be in floodwater. As far as folks go, you want to make sure to have a plan in place to notify people when there is flooding occurring on the farm. Make sure that folks aren't entering into that area before a person in charge has checked it for safety. And one other thing to keep in mind that you might not think so much about is that after the flood has occurred, especially if the floods occurred in a barn or some other type of building, there could be mold issues. So if you have someone that's very sensitive to mold or has asthma, make sure to go in and conduct a mold assessment as things dry out to make sure that folks are safe in those areas. Next, we're going to talk a little bit about extreme weather. What might that look like? So we're going to talk a bit about high winds, hail, and hurricanes. You can read a bit more in depth here, but when we're talking about high winds, we want to make sure that all of our infrastructure that is prone to blowing away is really well tied down. This would include tarps, for example. If you were tarping to reduce your weed coverage or something like that, making sure that those are well sandbagged is really important, because if those are flying all over your farm and they're hitting plants that are actively growing, any type of breakage that happens on that plant is going to create an open wound where pests can enter into the plant, and that'll ultimately lead to yield loss. So making sure that things aren't flying around that are going to injure your plants, your animals, or your employees is extremely important. I can think of one example. There's a farm that I've worked with in the past. They had a high tunnel that wasn't appropriately anchored into the ground, and it ended up injuring some employees. So now it's on their list of disaster preparedness things to do to make sure that tunnels are properly anchored and that all the plastic that's attached to it is also appropriately anchored so that it's not flapping around in the wind, causing potential damage to property, employees, etc. So with this potential increase in heat and precipitation, we've talked a lot about some of the pitfalls that we'll see, but there could potentially be some opportunities that we might experience in the future. So warmer temperatures and longer growing seasons could make growing new crops more adapted to warmer climates more feasible. One thing that a lot of folks think about in this case is introducing figs into their farming system. Figs enjoy a more Mediterranean, warmer climate, but hardy figs might do well in New York State, and especially New York City, and already are doing well in New York City in some cases, as the climate continues to warm, as winters become warmer. In some cases, you can see a yield benefit off of the increase in growing days throughout the year, and the increase in CO2 arguably could increase yields in some specific cases, but we're not sure that that's entirely offset by yield losses due to excessive heat. With this lengthening growing season, you could also have the opportunity to double crops. That means that you're getting something in early season. Maybe it's some type of leafy green, and that's finishing up pretty quickly, and then you're able to plant something behind that later on, maybe some type of brassica that you're able to finish off in a timely manner because you have this lengthened growing season and delayed first frost. Additionally, as folks come up with solutions to the problem of climate change, some opportunities may become available for farmers to receive payments with ecosystem benefits that they're providing, right? So that those ecosystem benefits might be carbon sequestration in the soil, might be the benefits that they provide for biodiversity, being a refuge for different types of plants and animals and wildlife, and perhaps for water quality, right? So if we're one of those few pervious surfaces in a sea of impervious concrete, we are able to better capture water and filter it through the soil and back into the water system as compared to a parking lot. So that's a definite benefit that urban farms in particular provide. Really quickly, I want to talk about how we might think about what our climate could look like going into the future. So at the moment, this tool is being updated, so keep that in mind. I don't think there is currently a projection for New York City, but the folks that run this tool at Washington State are on that. So this is the climate analogs tool. It's created by Washington State for specialty crop growers. That means folks that grow any type of fruit for the most part, mixed veg, etc., what a lot of urban farmers are growing. And it takes into account a lot of the different variables that might impact specialty crop growth, like growing degree days, heat degree hours, season length, chill hours, precipitation, etc. And it takes into account how those are projected to change under different RCP scenarios into the future. And then it spits out what a county is somewhere else in the United States that already has that similar metric. So for example, if we're going to talk about Buffalo, so right now, their primary crops are fruits, nuts, or apples, blueberries, raspberries, peaches, pears, etc. They are also well suited to grow potatoes, peppers, broccoli, tomato, squash, and they have some hay, soybeans, wheat, and corn. But as the climate changes under RCP 8.5, you see that their climate's going to be more similar to that of Salem, New Jersey, or Gloucester, New Jersey. And some of the crops that are more common there are peaches, cherries, plums, nectarines, etc. So if you're a farmer and you're thinking about what can I consider growing in the future as things change, what can I think about planting now, especially if you're talking about perennials that might take a while to get established. You can kind of use this tool to help figure out what's working in those climates that are more similar to what your climate's expected to shift to. So just some key takeaways really quickly. Climate change is a threat multiplier for agriculture in New York State. So farmers already experience a lot of pressures, economic pressures, labor issues, etc. And climate change is just that kind of one little thing that's added on top that makes all those other issues a bit more difficult to deal with. So preparing for the future now, seeing how that might impact you, really key thing to start doing. Farmers are already implementing and investing in practices that make their farm business more resilient to climate extremes. And it's necessary for us to have enhanced technical support, financial assistance, and research to increase the adaptive capacity of farms across New York State. And if you want to learn a bit more about these key takeaways or dig into them, I highly recommend reading this ag chapter in the New York State Climate Impact Assessment that was mentioned earlier. It's really a rich resource for farms in the state. So yes, please reference that. All right, I'm going to turn it over.
All right, thank you so much, Savannah. So everybody take a minute to stretch. Ooh, that's a lot to take in. Wake up a little bit. And in the last couple of slides here, we really want to ask the question. We wanted to start by presenting how is the climate already changing and what are the projections, and then how is that affecting and going to affect farmers, particularly urban farmers. But now we want to ask, why is this happening? Just a quick reminder if you have any questions about the science of climate change. So I'm going to try to go through these a little bit quicker, and you can always reach out to us if you have questions. So next slide. Can you do the next slide? Oh, great. Okay, so first off, what is climate? We can start to answer this question by thinking about the difference between climate and weather. And so next slide. One way to think about this is to think about what you may have in your wardrobe. So weather and climate both refer to atmospheric conditions like temperature and precipitation. However, the difference is the time over which this is happening. So weather happens over the short term and can change from day to day or even minute to minute. Climate is the long-term pattern of weather in a place. It's the average weather technically calculated over at least 30 years. And because of this, you can't really observe climate in real time. Weather is what we all feel when we step outside. If you want to know what today's weather is, just go outside. No one ever actually experiences the climate in the present because you can't step outside. So weather is what you're going to put on today. The long-term climate is like what you have in your closet, including clothes for the winter and the summer over the longer period of time. And when we talk about climate change, next slide, we're really talking about the change over the long-term period, 30 years. So how does what defines our climate and how does our planet stay warm enough? So we know that greenhouse gases in the atmosphere act as a glass ceiling and create an effect over the Earth's surface called the greenhouse effect. And you can see this really nice image of what's happening. They allow sunlight in, these greenhouse gases, in our atmosphere. They allow sunlight and warmth in, and they trap heat from the surface. And this atmosphere is actually very thin. And if we didn't have our atmosphere, we would not have a planet that we could live on. So next slide. So what is happening with our changing climate is you can see this on the two sides of the slide. You can see the natural greenhouse effect and what's happening because we are intensifying the amount of greenhouse gases in the atmosphere. So you can see here that the solar radiation enters our atmosphere from the sun, and then some of that is radiated back out, and some is the heat is trapped by our atmosphere. When we have more greenhouse gases in our atmosphere, like CO2, like methane, like nitrous oxide, we're actually trapping the solar radiation. Some of it still is re-radiated, but the heat is not able to escape. And so it's warming our planet. Next slide. So basically, I love this graphic because you can see here the Earth's carbon cycle. And it's a natural cycle, but climate change directly is related to this carbon cycle. We're basically taking carbon that has been stored for millions of years in the lithosphere, in the deep core of our Earth, as coal deposits or oil or gas deposits, and we're taking them out, we're refining them, using them, and we're emitting the gases out of our tailpipe or from our heating into the atmosphere. So we're changing this natural carbon cycle. We're taking the carbon that should be trapped underground, we're moving into the atmosphere, and then it's deposited down and stored in the ocean or on land. We could actually store more of it in the soil, which would be a great thing, and that's part of adaptation. We could actually store more of it in trees as well. That would be a great thing. That's part of adaptation, taking the carbon out of the atmosphere. Next slide. When I took climate change science with Dr. Art DeGaetano at Cornell, I work at Cornell, but I also took his class. For me, the most mind-breaking understanding of why climate change is happening is that it's basic physics. Physics is a as a phenomenon, you can't deny physics. We're basically taking energy from the sun, and there's a natural balance, an equilibrium to the energy budget of the Earth. And it has to be balanced at every layer of the atmosphere, including at the surface of the Earth. And so when we take that carbon and put it into our atmosphere, and we don't allow the heat to escape, that's heat energy. The only way that it can change, it has to be equilibrium, is to cause a change in temperature. There's nowhere else for that energy to go. Next slide. So what are these main greenhouse gases we've been talking about, and where are they coming from? On the left-hand side, you can see what they are. The biggest majority of our greenhouse gases is the one that's is the most abundant is carbon dioxide. And then we also have CH4, and we have nitrous oxide, and then a small amount. This is data from the United States greenhouse gas emissions from 2021. The smallest amount of our greenhouse gas emissions are these other gases that are hydrofluorocarbons, PFCs, that we use for coolants. On the right-hand side, you see where these gas emissions are coming from in the United States. So the vast majority of them are from, I'm trying to make that bigger so I can see. I'm going to go like this. You can tell I'm getting blind. Sorry. The largest percentage in emissions in the United States. We have a large country. People have to get places. So driving cars, driving trucks. The next is electric power production, and then industry, smaller percentage from commercial and residential uses, and then finally agriculture. In the United States, it's about 10%. It is a much smaller amount, but everything adds up. So it's important that we think about the ways our farms are emitting greenhouse gases. Next slide. So these gases have different atmospheric lifetimes and global warming potential. What does that mean? The atmosphere, and who cares really? Why is this important? It is really interesting. It's really important. You can see here, carbon dioxide has an atmospheric lifetime of between 50 to 200 years. Yolanda, what does that mean? I'll answer for you. You should all be thinking, what does that mean? That means when we emit carbon dioxide in the atmosphere, it's going to stay in our atmosphere for 200 years. That's a long, long time. Every other gas we measure relative to carbon dioxide. So we can say it has a global warming potential of 1. When we look at methane, we're going to compare it to CO2. So methane, you can see it has an atmospheric lifetime of about 12 years. Much lower time that it's staying in the atmosphere, but it's a much stronger chemical. So it has a GWP of 21. Nitrous oxide is a even much stronger global warming potential. It's doing more warming per molecule, but it doesn't stay up as long as CO2, and there's not as much of it. So the take-home message here is we should care about all of these greenhouse gases. The one that we really care about immediately or for the long term and immediately is CO2, because there's so much of it and it stays in the atmosphere a long time. We do care about methane and nitrous oxide as well. Next slide. So it's interesting. I think Savannah, in the beginning of this session, showed you the data that we have from ice cores. It's very accurate data. We take a sample, drill down into an ice core, and there are bubbles of our atmospheric gas in that ice core, and we bring them back up, and scientists can measure what was the content of the atmosphere at that time. You can see here, from going back thousands of years up to the present day, for CO2, then methane, then nitrous oxide. And to me, this is just a phenomenal graphic that shows that our planet is warming. There's really no, our greenhouse gas emissions are increasing. There's really no denying it because you see it in 3 separate gases, the measurement of that, they all increasing in this industrial revolution, since the Industrial Revolution. Next slide. And this is where I should have waited to say this. Next slide. This is where it does compare to global temperature. Same kind of trend line from 1860 to 2000. You see on the left-hand side, the change in what we call an anomaly, the change from the average of CO2, carbon dioxide in the atmosphere. And on the left-hand side, we see temperature anomaly. So what's the change in temperature? And we see that in the beginning of this time period, in the 1860s, temperature was much cooler. As we see this rise in CO2 on the trend line there, the black line on the graph, our temperatures are increasing, and it's a dramatic increase. Okay, next slide. So I also love this graph because it's kind of answering the question, could this be a natural phenomenon? What is causing, again, another way of looking at what's causing this warming? And so this shows you the different activities. I'm going to take my glasses off again. So at the top are the long-lived greenhouse gases, the short-lived gases, aerosols, and clouds. And those can be summarized as human activities, right? And there are some of those human activities that cause some cooling, like aerosols. If we put them in the atmosphere, they actually cool the atmosphere. But the vast majority of the things we humans are doing, including those long-lived gases, are causing warming. And then there are also some natural causes of climate warming, radiative forcing. But when you look at what's natural, there's some natural cooling and natural warming. It's a very small amount. We cannot explain this huge warming that you see on the bottom. Total net, the change, net total due to human activities is what is causing the vast majority of that warming of our planet. Next slide. So just a couple more slides to wrap this up, and then we'll turn it over to Yolanda. So this shows you U.S. carbon dioxide emissions by source, again, answering the question, where is this coming from? From the period 1980 to 2020, we see coal. Over that time period, the emissions from coal have declined. We see natural gas also decline. Actually, our emissions in the United States are declining slightly, but petroleum has increased and then slightly declined. You can see more of our emissions now come from petroleum and natural gas than coal. And by end use sector, again, what is emitting these fossil fuels? It's commercial, residential, industrial, and the large majority is transportation. Next slide. We want to just really touch on the greenhouse gases that are important to agriculture. So what are these sources of methane emissions? 30% of them are actually from natural sources, like the methane that is released from wetlands or oceans. 18% of them are from fossil fuels, natural gas and coal, a lot of lost emissions there that are important. And then the whopping 52% comes from anthropogenic agriculture emissions. That means human emissions from agriculture, and that includes methane emissions from cows, rice paddies, burning forests, landfills, animal waste, and domestic sewage. And again, to keep in mind that these are important. If we can get these under control, we would reduce short-term warming of our planet because methane is so potent of a gas. Next slide. Nitrous oxide is the other gas that's really important for agriculture because we emit it in our use of fertilizers. So where are these emissions of nitrous oxide? Again, there are some natural sources, 73% of them, but then there are human sources. 27% of the emissions actually come from soil emissions when we don't properly apply our nitrogen fertilizer. It can be emitted in the atmosphere when we burn biomass, industrial burning, and then from cattle feedlots. And nitrous oxide, there's not as much of it. We're not emitting as much as other gases, but it is 310 times more potent. So it's important to get those under control. Next slide. I touched on this earlier, just the difference of global warming versus climate change. Global warming, we really think about the gradual increase of the Earth's surface temperature, but climate change, we think about the long-term change in all these weather patterns, both temperature, how is that going to affect precipitation? How is it going to affect pests? And all these things that are important for farming. Next slide. We talked about this already. Warmer air holds more moisture. So next slide. When we think about climate change, again, it's important to think not only about temperature increase, but melting glaciers. We wouldn't think that would affect urban farmers in New York City, but it probably will because it's going to cause rising sea levels, ocean acidification, or with rising sea levels, we can talk to Sea Grant to get more information, but we would often see in parts of Long Island areas where saltwater intrusion is affecting farms on Long Island because of sea level rise. We see this increase in extreme weather events. And then when we think about climate change, it's also causing shifts in ecosystems, in forests, in wildlife, and really devastating effects on biodiversity. So at this point, I want to turn it over, and Yolanda is going to really help us bring it home to our own situations.
Yeah, so I just want you all to take a moment to reflect on your own climate change story, thinking back at what climate extremes have really impacted your farm, or if you don't have a farm, maybe your community garden, or just you're living in an urban area. Have you experienced an extreme weather event or noticed changes in either increased heat? And if you can think of that example, and we're going to show you another example on the following slide. This is an urban farm in New York City called Brooklyn Grange. And Ben Flanner, the co-founder and CEO, explains that the Grange has dealt with pests, extreme rainfall, heat waves, and high winds, heavy precipitation events such as more than 8 inches that fell within a 24-hour period during Hurricane Ida in 2021. And that led to damage in both crops and buildings. He said that the drainage system could not handle the rain, which left damages and results in changes and increase in our insurance premium. So that was a direct result of extreme climate events. High winds are another concern, especially for rooftop farms. When clobbers our yields, half your plants will be dead in the morning because they got hit with a 30-mile-per-hour wind. Typically rooftop farming does experience high wind, but something like 30 miles per hour is definitely an example of extreme weather event. Farmers and farm workers at the Grange are struggling with the frequency of high winds and heat waves. The heat spells are brutal. Often it means starting when the sun is coming up and being done by the middle of the day. So that goes again to another adaptation strategy of adjusting when your employees start on the farm to avoid those really intense heat waves during the day. Next slide. Other ways to get involved. If you're based here in New York City, highly recommend the Climate Tech New York newsletter. There's over 11,000 subscribers, and you get a weekly digest of all climate tech events and news happening here in the city. There's different climate tech groups throughout the US as well. I believe there's one in San Francisco and Seattle. If you're interested in more in-depth climate change education and training, there's Terra.do, Climate Base 1.5, Climate Reality Project. These are all independent organizations that do provide their own certification program if you're interested in going just more in depth in this subject matter. And lastly, Climate Change Cafe is a community here in New York City that connects you with other people that want to talk about climate anxiety, opportunities for impactful local organizing, and keeps you motivated through camaraderie, creativity, and fun. So that's the website there if you're interested in checking them out. And other ways to stay in touch, we have a social media page, Instagram, urbanag.nyc. That's our Harvest New York Urban Ag Team Instagram account. Mayor's Office of Urban Agriculture is NYC Urban Ag, so it's just inverted. On our website, we do try to post regularly upcoming events, and we also have a link if you would like to sign up for our Market Growers Update, which is our quarterly newsletter that we also post about upcoming events, but provide technical assistance around production. So we'll let you know the latest pest and disease pressures that we are seeing here in New York City. Next. And what's next for the next session? We'll be covering climate adaptation. And so that is what session 2 is all about. So yeah, if you would like to get in touch with the Urban Camp team, this is our email address listed on this slide, and feel free to reach out, and hope that you got a lot out of this webinar. Thank you all for attending.
Thanks.